Okay, good afternoon. So, as I told you, I will go and teach the next chapter, and then I will give you time to practice on Friday and Monday, and then we will have the test on Tuesday. Okay?
Yes.
So, this chapter is actually a very important chapter. This is chapter 5 in our book. And it is not probably exaggeration if I say that most mathematics is talking about functions in some way, yes? So that is extremely important to have a good understanding of what a function is. Okay. I want to talk a little bit more abstractly, a little bit more rigorous than the way that is treated in the book. But I think it is manageable for everyone. Yes. So a function is an operator, is like a machine that gets one or more inputs from you, do something on those inputs, and then give one or more pieces of information back to you as the output. So that is the meaning of a function, as simple as that. But it's completely generic. So if I want to have a good understanding of what a function is, so you can imagine something, a diagram like that. So you have a box, this is your machine. In this box, you send an input, any piece of information, anything you can put in that. You can imagine anything. It can be an object, it can be a number, it can be a letter or whatever, yes? And then this operator, this machine, which I will call it a function, will do something on this input and gives you something back, which I call the output. So input, this is output. Okay, so this is the product, but this box itself, depending on the operation that this will do on your input, is called your function, yes? So let me call it with the letter F. This is common, that we denote a function with letter F. These are the letters reserved for functions, F, G, H. These are typical letters used for denoting a function, but of course it is not compulsory. You can use whatever you like, yes? So what is the meaning? And then the output that you get, according to this notation, there is a symbol for that. You write F, and then in pair of brackets you put X. So I want you to understand this. You see, I send an input called X. It doesn't mean it is letter X or whatever. It's just a representative of what I can send into this machine as an input. X is just a representative, is a name for the input, yes? And then this machine does something on the input, and it gives you a product, something output, and that output generically is denoted by this letter. This is called F. You read it F of X, and this is the way that you have to respect. This is the way that you write the output. Yes. Sometimes mathematicians write it simpler. They just put X to F of X, and on the top of the arrow they put F. So it means that X is sent to F of X in the when F applies on it. Let me give you some simple example, okay? So here, assume that this box is a machine that squares any number that you send in. Okay, so for example, let me draw this for you. Okay, so what does it mean? So let me write it a little bit more carefully. So I send X in, and X squared is out. So if you see this, you need to interpret it in this way. F is a machine, is an operator, so that when I send X in, it gives me X squared out. Yes? So first of all, by looking at this diagram, you understand that X cannot be anything. For example, I cannot send the book in. Yes? Because if I send the book in, the output should be book to power 2, which is meaningless. By looking at this function, you realize that this input should be a number, otherwise this cannot operate on it. Yes? So for example here, if I ask you, when I send 1 to this machine, what will be my output? Because it is 1 squared, which is 1. But if I send 2 into the same machine,
4.
I will get 4 back. That's the notion of function. And I cannot send any object in except a number, because by the definition of the function. These values that are acceptable for sending into this machine as an input is called the domain. Yes? The collection of all objects that are acceptable as an input for my function, the whole package is called the domain of the function. And if I gather these outputs into a bag, this bag is called the domain, this bag is called the range. Yes? So, input, output, the collection, mathematical term is set. The set of all inputs is called the domain of my function. The set of all outputs is called the range of my function. Yes? This variable, so here, if I have a function f, I send x in, I get a value y out. Yes? Of course, this is, by the way, a terminology. I use the value, but value makes sense if y and x are numbers. But in the language of functions, even if y is not a number, I can still call it the value. The correct word is the output, yes? This one is called the independent variable. Yes, this one is called dependent variable. The name is actually a good name, because in principle, from the domain, you are free to choose whatever you like to send in, but as soon as you decide about one of them, the output should follow. It depends on the input that you put in. So this output depends on the input. But in principle, input, you can choose whatever you like from the set of domains. But as soon as you choose one of these particular values, this is not the case that it can also choose one of these values. This has to obey, yes? When I send 1 into this function, when I decide about the input, that is the whole point. The output is already clear. It has to be 1. And if I choose 2, this cannot be any number else except 4. Yes? Now I have to, if you want, you can change the places. Yeah. So, the values that we send in are called independent variables. The value we get out are called dependent variables. It's clear why that is the case. So, for example, let me ask you some questions to test your understanding here. Do you think that I will have number 3 in my range for this function? Do you think that it is possible that I get an output 3 here? Yes?
Well, x could be the square root of 3.
Yes, so it means that if I send square root of 3 into the same function, definitely my output will be a square of this number, which is the square root of 3. Is that right? So for example, so this is clear. But let me ask you something. Do you think I can have minus 5 in the set of in the range of this function?
No.
So can you imagine a number so that you send in, and after this f operates on it, you will get minus 5 back?
No.
It's clear no. Yes, because whatever I choose here, as a number and I send in, it will square this one. Even if I send negative numbers in, because I am squaring it, this is the role of this function, I will get up positive values, yes? So this means that I am not allowed to write -5 in the range. Yeah, is that clear?
Yes.
So if you think as a function in this way, it's really, really easy to understand what is going on. Another, probably the most important thing about a function that I haven't described yet is that when you decide about the input, the output is uniquely determined. This word uniquely is extremely important. Yes? So it is not possible to send a specific input and you get 2 outputs or more outputs. This is not the case. If this is going to happen, that operation is not a function operation. Yes? A function means that whenever you choose your input value or values, the output value or values should be determined in one unique way. That is extremely important. Is that clear? Yes? Okay. And by the way, that is, for example, you go to ICA and then I don't know, you have some shopping and then you have this barcode, yes? Then you can imagine that this is more or less a function. We can call it a pricing function, yes? So for example, I can have a function, let me call it P for pricing or giving the price, and then you go to ICA and then you, I don't know, you send in whatever you are deciding to buy, and then what will go out is the price of that commodity or whatever you want to buy, yes? And then you can imagine that this follows always this one, yes? It means that it is not possible that you take an item and when you want to find a price, you will not get 2 or 3 prices for the same thing, yes? Otherwise it would be meaningless. So that is why that machine is actually a function. You just operate it, yes? You take it and just show it to the barcode and then the price of that thing will be shown at the cashier or whatever. So that's, you are working with a function. Is that clear?
Yes.
But so here we learn that one input cannot give rise to more than one output. But do you think the other way around is possible for a function? 2 different inputs, is it possible 2 different inputs give rise to one output, the same output? Yes? Yes, for example? Exactly. At this level, we can say 2 and -2. Even if I put -2, both of them will go to 4. Yes? So it is possible that I have 2 different values assigned to the same value. Here, in pricing machine, this is also possible. Might be, I don't know, you buy a chocolate and might be you buy an ice cream, accidentally they have the same price. Yes? So is that possible? We have 2 different commodities, but they have the same price. But the other way around is not possible for being a function. Is that clear? So that's extremely important to realize. So this is why we can safely say that this one, we say that y, the output, this is the terminology I want you to learn, y is a function of x. Yes? And then if you want to write it mathematically, because you know that drawing these diagrams could be, even though it is illuminating, but it is hard to write all the time, especially if I have more than one function. So the way that people write it, they will say that f operates on x, instead of drawing this diagram, we just simply write that. F acts on x, you have to put this pair of brackets, that is the punctuation rules, and then it becomes equal to 1. Yes? So this is mathematical symbol that we use instead of this illuminating diagram. But you need to interpret this exactly in that way. Is that clear?
Yes.
Okay. But let me start talking a little bit more about functions abstractly. we can assume that I can have functions with more than one input. Yes. For example, I can imagine a box f that it needs two inputs. Let me call one of them x. Let me call another one y. So this machine, this operator, needs two inputs. It might be the case that it gives you 1, 2, 3 or more outputs, or it might give you, for example, let me give you, it gives you x plus y. So that is actually, you can use it in your calculator, yes? So you punch one number and then you put plus sign. Plus sign is telling the calculator that it is a function, addition function. It needs two inputs and it gives you one output, yes? That's also a good function, yes? So for example, if I send 5, let me write, by the way, s because of the sum. It's better name, yes? So if I send 5 and I don't know, I send -7 into the sum function, what will be the output? -2. Yes? Yeah?
Yeah.
The people who are actually sometimes working programming, things like that, they should be very familiar with these kind of things. So for example, assume that for some reason you are interested in both the sum and the product of two numbers and you want to reserve them somewhere in your code when you are coding, yes? So it means that, let me call it another function. For example, let me call it capital F this time. I send two inputs in, x and y, but then I am interested in three outputs. Yes? For example, the first one is x plus y, the second one is x minus y, and the third one, for example, is x dot y. So that's also a function. Yes? So, but this function, you need to feed in two inputs, but the output is 3. And the order here becomes very important. For example, in this function, if I send 2 and 3 into this function, what do I get at the end? I get as the first row what? 5. As the second row, -1, and the last one 6. Yes? And then, of course, this is completely beyond the level of your book, but it is really understandable, okay? If I want to write this mathematically, how do I write this mathematically? If I want to use similar notation here, what you have in your book is at most one variable for input and one variable for the output. But I don't think we should relax this limitation. We don't need to limit ourselves for one input and one output. We can have more than them. Yes?
We could write f of x comma y.
Yeah, exactly. That's the same. This is the same symbol notation. So we say that s acting here on x comma y, and then the output is x plus y, and that is just one single number in this case. Yes? But be careful. Here, x and y is what we called an ordered pair. This is extremely important to respect the order. But order here is irrelevant because of the structure of the function. Why? Because this function tells you that if you feed me with an ordered pair with the first number x and the second number y, I will take the first number and add it to the second number, and then I give you the output. In this case, if I ask you what is the answer to this, this will take from you y, take x, and then add them. Of course, in this case, the output is the same. Yes?
Is it a comma or a multiplication?
No, this is comma. Yes, this is comma. We have to separate them, yes? But sometimes it is not the case. If I want to write this function in mathematical term instead of diagram form, what should I write? Capital F acts on how many inputs?
2.
2. Let us say the one on the top is the first one.
Yeah.
The one on the bottom is the second one. But what would be the output? The output is a triple, yes? Is a triple, yes? The first component is x plus y. The second component is x minus y, and the third component is x dot y. Yes? So even though you will not face something like this in the book at all, but I don't think it is hard. It's completely understandable if you really want to understand the function from an operation point of view. Is that clear?
Yes.
Okay. Let me ask you something here. So let me write this, for example, let me change my letter to G this time. I have this function x, this function, so the output is, say, x plus 2x squared. For the time being, I limit myself to numbers, okay? So by this way, you immediately understand this x cannot be like Ika, yes? So what I put in is a number, because otherwise this doesn't make sense. I am multiplying this by itself, multiplying it by 2, adding it to itself. So this x definitely should be a number, yes? Okay. If I ask you, what is 5 when I add 5 to G? What is the answer? What's the answer?
51.
So how did you get that? You replace x with 5, yes? Because this function, you need to understand it in this way. This function is an operator so that when you give a number to it called x, this will take that number, add it to 2 times of its square, and whatever it is, it gives you as the output. And now you are feeding the same machine with 5. But this machine is the same machine, so it will do the same process on every input that you put in, yes? So including 5. So it will take number 5, which is the input, plus 2 times its squares, and whatever this number is, it would be the output of this, which is what?
100% sure.
This is 25,
55.
55. So the output is 55. Now let me ask you this one. I will send in a minus 1 into the function g. What is your expectation? I'm sending a minus 1. For some reason a is a number, I am interested to send in a minus 1. So what will be the answer? What will be the output?
A minus 1 plus 2.
Every x should be replaced by a minus 1. But of course, you should also respect the punctuation rules. This is not a correct way of writing, yes?
No.
So I have to write a minus 1 as my input, and then this input is squared. So that would be the output. If I need, I can simplify this a little bit if I need. Otherwise, that's completely okay. I will keep it like that. Is that clear? Okay. Another thing that I want to talk about, let us talk a little bit about the domain of the function. So let me have a function, call it capital G this time. I am sending a number in, and I am saying that this will give you 1 over x. That's also a well-defined function, apparently. Whatever number I give to this function, it will give me the reciprocal back. But here, I hope that you agree with me, there are some limitation for the numbers, for the inputs that I can put in. Yes? So, for example, do you remember the function that I started with was the squaring function? Do you think, if I stick to the set of real numbers, do you remember every number that you can imagine, except complex numbers that we forget about it for the time being? Any number that I can imagine can play the role of my input. Do you agree? Because whatever I put in, that function will square it and give it back to me. Do you think the same story happens here? So let me ask you, by the way, if I ask you what is the domain of the function, the symbol we use is this, D for domain, and then we put a subscript f. This I read it the domain of the function f. What is the domain of the function f? It means the set of all possible values that I can choose as the input. What is that? Yes?
X.
No? No? X is a representative of that one. The set of all values. For example, can I put 1 to this function? Can I feed this function with 1? Yes. Can I feed this function with square root of 2? Yes. Can I feed this function with 3 over 5? Yes. What is the set of all possible numbers that I can feed this function with? Yes.
Real number?
The set of real numbers. So that is called a domain. Yes? That is called the domain of my function. Here, tell me, can I say the domain of this function g is also R? Yes, Rasmus?
It's R with the exception that x cannot be 0.
Exactly. So whatever you want, you can choose for x, except one exception, and that is 0. Because if I accidentally choose 0, I will get some error from the function. And by the way, this happens in the calculator. If you just write 1 divided by 0 in your calculator, you get some error message in some way. Yes? That's exactly what happens. It shows you that you are using the function for a number which does not belong to its domain. So I cannot answer it. I can only answer for the points which are in the domain. So here, the domain, if you want to really, so you see I write capital D for domain. The name of my function is of course capital G here, but I have to use it as a subscript. And then I would say the set of all numbers is acceptable except 0. But you haven't studied set theory. This is a wrong way of writing that. The correct way, if you want to follow the punctuation rules, you have to use curly brackets around. Because collection in mathematical term is called a set, and in sets we need to write, we have to open curly brackets and write the elements and separate them by commas. This is the standard way that I can show a set in mathematics. So that is why I would say that the sets of R excluding number 0. And the 0 is clear, yes? Because if I, by mistake, feed 0 to this function, the function will want to give me 1 over 0, immediately realizes that this is not defined and it will complain, yes? But except 0, do you think I have any limitations? No. Yes? Can you imagine of a function with more limitations? Here, what was my limitation? One single limitation, and that was 0. Except 0, I can put any number that I like in. Can you imagine a function with a lot of limitations? Anyone else? What do I mean? You can just use this diagram. For example, let me call it capital H, this machine, and then give me an output so that I have more limitations than just 1 point for that function. Yes, Rasmus?
We could first we could just use the square root of
Exactly.
x, and that
Square root of x.
almost half of all numbers are
Yeah,
not allowed.
almost half. Yeah, because the notion of half doesn't make sense when it comes to infinities. Okay, but you are right. So it means that. So can I use 1 for x?
Yes.
What is the answer?
1.
1. Do you remember I told you sometimes people say square root of 1 is plus or minus 1. That is wrong. If square root of 1 is plus or minus 1, is it a function or not?
No. It's not a function.
It's not a function, yes? Because I told you that the main property of a function is to generate one single unique output for every input, yes, in its domain. So you see that the square root of x is just a positive. So here, I don't have any problems with using 1 for x. I don't have any problems for using 4, using 5. Everything is okay. Even 0, do you think I can put 0 instead of x here?
Yeah.
Yes or no?
Yes.
Yes, but if I put minus 1/2, does it make sense? No, because the square root of minus 1/2 is not defined in the set of real numbers. Yes. Okay, can you tell me what is the domain in this case? You can imagine that all possible values that I can use for x to make a meaningful output. That is the meaning of domain. Yes.
A non-negative real number.
Non-negative. So I don't know. Might be you haven't studied that much, but if you want to really respect to write it, you would say the set. I don't need you to learn this one. The set is this domain is equal to the set of x's where in R this means belongs to, and then this vertical line means such that x is greater than or equal to 0. This is not hard to learn, but this is not in your book. What you mentioned is completely okay for me. So you would say the set of all non-negative numbers. But if you want to express this English sentence in mathematical symbols, you would say the domain of f is the set. Curly brackets means the set. What do I put in the set? I put in the set x's, which are real numbers. X belongs to the set of real numbers, not all of them, such that x is greater than or equal to 0. But don't bother yourself about writing this very mathematically. You can just express it in English sentence. The set of all non-negative real numbers. Yes?
Alright.
Yes?
Shouldn't it be h below?
Oh, yeah, yes. Thank you very much. Jenny, do you want to say something like
How come the 1 was possible there? Because doesn't it give like, you said something about the square root of 1 is 2, so it couldn't be, like the square root of 1 could be both minus 1 and 1, so...
This is wrong.
Okay.
Square root of 1 is always 1.
Why
If you
can't-
take your calculator and calculate it, it gives you 1. Yes? So if some people write square root of 4 is plus or minus 2, that is not correct. If you take your calculator and calculate square root of 4, it always gives you 2, not minus 2. Yes? So the reason is that this is a little bit of confusion. If I ask you x squared is equal to 4, and if I ask you find x, then there are two numbers, plus 2 and minus 2. So it means that x is square root of 4 plus and minus. So you put plus and minus before square root of 4, not because the square root of 4 is plus minus 2. Is that understandable?
Yes.
Yeah. I have talked about this in my first videos when I was talking about exponents. I would recommend you, if you want, you can go back. But for the time being, remember, if I ask you square root of 4, take your calculator and punch it 100 times, you always get 2. Not even one single time you get minus 2. Yes? That's always the case. Okay. But let me ask you something. Is that understandable for you? That finding the domain... So let me ask you the question in this way. Finding a domain, the domain is easier or finding the range? If I give you a function, is it easier for you to understand the domain or is it easier to understand the range?
Domain.
Which one is easier? I would say the domain is easier. Yes? Because you want to choose the x's so that the output is meaningful. But if you want to talk about the range, you need to have a good understanding of what will happen when I feed in all possible values in. And because I am facing with infinitely many numbers, it might not be easy to be able to come up with a conclusion that what the range is. Yes? For example, can you tell me what is the range of this function? What is the range of this function? This function, capital H. Yes?
Shouldn't it be 0 to positive infinity?
Exactly. So here, this is one of those functions whose range and domain coincide. So if I ask you what is the range, you would say the set of non-negative real numbers. If I ask you what is the domain, it means that that's the same thing. But can you tell me, here the domain was this, but what is the range? What is the range of this function? So the range means, is there any limitation for my output? Do you think my output can cover everything? This is the way that you need to think. I want you to understand these things, okay? These are not dealt that much in the book, but they are extremely easy, but very important. I want to discuss together to have a good feeling about functions. Because functions is one of those lessons that you should have a good feeling for. Otherwise, memorizing is not useful. So let me rephrase this question for everyone, then I will ask Oscar, okay? So let me ask you this. So let me write this here on the board. X, this function h, the output is square root of x. We talked about the domain. I hope that every one of you agrees that this is the right domain. Okay, and then when I talked about the range, I mean the numbers that this can cover. Do you understand what is the difference? Here, when I want to talk about the domain, I have the set of numbers that I can use as my x. That was easy. I realized that I can use every x except negative values for x. Yes? But now assume that I have the set of my inputs ready for me. I have to apply h on each one of them. It will give me some numbers here. Do you understand? And I want to see that if I put them in one collection, what that set is. That is not that easy to understand if the function is complicated. If the output rule is complicated, guessing this is not an easy task and sometimes impossible. Yes? But so here, the output is also the set of non-negative integers. But let me test this function. So what is the output here? The inputs are every number except 0. What do you think the outputs will cover? Yes? Yes, Simon?
Any number between -1 and 1?
No. So let me tell you. First of all, do you agree that if I want to answer about the range of this function, I want to see which numbers are covered. Let me ask you one question. Do you think 1/2 will somehow covered by this function?
Yes.
For which input this is covered?
2.
For 2. So 1/2 is in the range or not?
Yes.
It is in the range because it is covered for some value. Which value? 2 in this case.
Yes.
Let me ask you one more question. -1/2, is it covered?
Yes.
For which value of input?
-2.
-2. So that is also covered. So this is the way, because this is why range becomes harder. You need to imagine the numbers that are eventually covered and the numbers that cannot ever be covered. This is hard. Okay? But let me say, do you think this number will be covered?
Yes.
With what is the input for that? Just say it.
Square root of 2.
Okay, let me make it a little bit more tricky. Do you think that this number will be covered? Do you think the square root of 3/3 is covered? If the answer to this question is yes, it means this number is in the range. If the answer to this is negative, and you can prove it to me that this is negative, it means that we have to exclude this from the range. So the question is still open. Is it in the range or not? If yes, tell me why. If no, tell me why. Yes?
It is.
First, yes or no?
Yes.
Yes. Okay, so how is it covered?
It's square root of 3, right?
The square root of 3, yes. Square root of 3, yes. A square root of 3. If I put a square root of 3, what will be the output?
But 1
It
over.
would be 1 over the square root of 3.
Which is
But 1 square root of 3 is that number.
Yes.
Yes? Because you can write it as multiply, do you remember?
Yes.
You can just do this trick and then it becomes the square root of 3 divided by 3. So a square root of 3/3 is another name for this one, and this is definitely covered by that one. So that number is still in the range. Is that correct or not? Let me make it simpler. So you don't need to, by the way, could I say that this is covered by this number? If you are smart enough, you don't need to be bothered. This number also covers that number, yes? Because this role of this function is to interchange the numerator and the denominator. If I interchange the numerator and the denominator here, I will get that one. So this is definite. This method is correct. This method is also correct. So anyway, that number is covered. Yes? Okay, now you have a good understanding. Is there any number? Is there any number that is not covered? Yes.
0.
Exactly. Can you tell me why? Why 0 is not covered? Is it possible? Is it possible?
Half of a 0.
Okay, exactly. So is it possible to feed something in so that the output is 0?
No.
No, because if I feed this in, the answer would be 1 over x. Is it possible that 1 over x becomes 0? No, because this fraction, numerator of this fraction is 1, so this fraction cannot be equal to 0. Is that understandable?
Yeah.
So definitely 0 cannot be covered, but it is not enough yet. Is 0 the only number that is not covered?
Yes.
Yes. Why? Because any number like y, which is not 0, is covered with 1 over y. Yes? Is that understandable, or you are confused now? Is that understandable? So you see, you told me that 0 is not covered. I agree with you. So 0 should be excluded. My question is that, is there any other number that have to be excluded? If you just say, no, that's not mathematics, you should say no y. That y part is that if y is not equal to 0, then this number is covered by 1 over y. Agree? So if y is not 0, it is covered. And if y is equal to 0, it is not covered. So the range is everything except 0. Is that understandable? But what I want to tell you, this understanding of the range is important for me, that you know. But finding the range, if you make the function complicated, even I cannot find the range. And sometimes it is impossible. Is that understandable?
Yes.
Yes or no?
Yes.
Okay. Now, let me try to play around a little bit with this concept so that you can understand that better. Okay, so here, let me give you this function. For the time being, I want to keep these diagrams, but then I will switch to mathematical symbols. Okay, so I will give you this function. X, I send it to a new function, let me call it u function, and it will give me this. It gives me this, yes? Is that understandable? So I don't think, if I want to write it mathematically, by the way, what should I write it mathematically? I would write u acting on x, yes? It gives me square root of x over x minus 2. So from now on, I don't know if the book is precise or not. I have seen many textbooks, they write the function u of x equals to this one. This is technically wrong, yes? Because I told you that if I show this one, and this one, which part of this is the function? U is the function. This is the input, this is the output. And u of x is this one, is the product. So in principle, you should say the function u defined by this. But of course, this is people are sometimes lazy to write the correct one. They say the function u of x. But u of x is the output. Just appreciate the difference. Okay, now let me ask you about this. Let me ask you about this. I want to give you a little bit of time so that you can think about the domain of this function here for me. I will pause recording the video and I ask you please think about the domain of this function. Okay, ready? Not yet? Who is ready? Yes, Simon again, so I will give you the chance.
Okay, no negative numbers and not 2.
Not. Exactly. Why? Because if this is going to make sense, I shouldn't find any error message. But I know that I have some operations with limitations here, yes? Squaring root operation has some limitation. I'm not allowed to put negative numbers for that. And then I have also another restricted operation. Division is also a little bit restricted because the denominator cannot be equal to 0. Division by 0 is forbidden. But for the whole expression to make sense, I have to care about this operation and that operation simultaneously, not separately, yes? So, if I am only having this in my output, I would say x should be greater than or equal to 0. But if I am careless and I say that this is the answer, then I will have a mistake here because I am allowing for 2 for x, but 2 makes the denominator equal to 0. So if I want to write the domain, in principle, the domain of u is, if you write it in the exam like that, I accept it from you. So I should say greater than or equal to 0, and, this is important, and x is not equal to 2. But if you want to write it properly later, this would be the set of all x's coming from the set of real numbers, but not all of them, such that x is greater than or equal to 0 instead of and. Do you remember? I can use this symbol. X is not equal to 2. Yes? That's the domain of my function. Understandable? But hopefully you understand finding the range is not easy at all. If I ask you, okay, I choose all these numbers, all non-negative numbers except 2, and start feeding them in, I will get some outputs one by one. Is there any part, which numbers are covered and which ones are not covered is not that easy to answer here. Yes? I think, I don't know, if you know a little bit about quadratic equations and things like that, you will be able to solve that one. But I'm telling you, if I make this harder and harder, at some point we will not be able to do that. Okay, so that's very good. You understand what is the meaning of the domain. Is there any problems here? Understandable for everyone? Okay. Another exercise that I see in the book without talking about it is we can compose functions. We can combine several functions together. What does it mean? It means that I have one function, I feed it in with some input, I get an output, I take the output of this and feed it into another function to get a new output. This is called composition of functions. Yes, for example, let me give you two functions, f, and I define it with this. X goes here, the output is 2x plus 5. So if I ask you what is the role of this, I would say that whatever number I give to this function, it multiplies the number by 2 and add 5 to it and gives it back to me. Yes? Now I have another function. Let me call it g. This I want you to understand, to see how do you think about this. I put x here, and then I will get 5 minus 3x. The first thing that I want you to understand, this x that I am using, this is not a good question to say, is this x the same x? I want you to understand, in the language of functions, this is not that meaningful. X is a representative for me that I can show the input. Whatever you can call it a box. You can call it a star. I don't know. I can write this function in this form. By the way, that's very good that I brought this up. What should I put here? Can you tell me?
Whatever you want.
No. Be careful. In this context, look at what is on the board right now. I have to put f. Because I want you to understand, names are not that important when it comes to functions. The role of the function is important, yes? So, you see, I am using a symbol, a star, to show what do I mean. I am saying that I send the input to a machine, it multiplies the input by 2 and add 5 to it. On the other hand, here on the second line, I am sending X to this machine F, and it is doing the same job for me. So it doesn't matter if this function is called F, I have to call that one F as well, because they are doing the same thing. Is that understandable? What they do matters. Is that understandable? Okay. So, now let me ask you one question. I want to apply these machines one after the other. I have this one. I have this one, F, G. I send X in, and then I send it here, and I send it out. I want you to answer the question mark. This is a very extremely important role for functions. So you see, I have one operation after another operation. So this means that I take X, send it to machine F, it gives me an output, I use that output for a new machine G, and it gives me a new output. And I want you to answer me what is the question mark. Yes, please.
It should be.
You don't need to calculate it in your head, but just tell me what to do. So what is this intermediate step missing? Can you tell me?
Yeah, it's that's what you get from X.
Just name it. X is in. What do I get?
What do you mean 2x plus 5?
Exactly, 2x plus 5. Yes? But now, 2x plus 5 is playing the role of the input of the second function. So can you tell me, what is the role of this? You need to read the role. Forget about the names. You need to interpret this in this way. G is an operator, so that when I put x into it, it writes 5 minus 3 times the input. This is the way that you have to interpret these symbols. Yes? And now, what is the input for G now? It is 2x plus 5. So what will happen for this input? G only has one duty. Writes 5 minus 3 times the input. So this will give me 5 minus 3 times what?
In brackets 2x plus 5.
Exactly. Yes? So that would be the output after I compose these two functions one after the other. Yes? So then what is it? Let me simplify this, by the way. Let me simplify that. So, let me write it here properly. So x we send in, it goes to the machine F. I get something out from machine F. I send it to G, and I get that number. So if I simplify this for you, it becomes 5 minus 6x minus 15. So it becomes minus 6x minus 10. Yes? Yes or no? Okay, now let us see that if I interchange the order of these functions, do you think that I will get the same input in general, output in general? So let us think. So this time, I send x to G first, and then I get the output from G, and then I send it to F. Then I want to answer this question mark here outside. So what is the answer that? What is the final answer there? So, what is this intermediate step? What should I write here? X goes to G. The output is 5 minus 3x. But then can you tell me what should I write here? I need to read it in this way. What the function does, multiplies the input by 2, add 5 to it. Yes? The input is now this one. So it multiplies that by 2. And then adds 5 to it. And if I simplify that, it becomes 10 plus, this is 15, minus 6x. So you see the output is this one, the output here is this one. So they are not the same. So if I change the order in which that I'm applying the function, there is no guarantee that I get the same output back. So in composing the functions, the order in which you compose matters. So you have to be careful. You are not allowed to interchange in any order that you like. Yes? Okay. I can also compose the function. By the way, combine is not a good word. The mathematical terminology is compose. This is called composition of functions. That's more or less the same as combination, but the word that in mathematics we use is composition. Yes, be careful. So let me write one thing here and want to give it as an exercise to you. Okay, so what happens if I send x2 with these two functions? I have this.
Vill du helt kompromissa? Vill du ha det? Nej, vill du ha stå det? Oj. Men så ska du stå och bruka det.
Now just please do that. If you can solve this one, it means that you're really on the safe side. You understand what is in the functions here. Okay, if any one of you is ready, you can read your answer. Oscar, do you want to read your final answer? I will come to you. I want to write the answers here to see which one is correct.
My final answer.
Yes, only final answer.
Minus 15 minus 18x.
18?
18.
What is yours, Jenny?
I got minus 15 plus 18.
Plus 18? Minus 15 plus 18.
What?
So Jenny, Oscar.
Oh no, what?
Anyone else? Tim? Okay, that's the same, yes? Yeah, okay. So Tim?
What did I do wrong?
Okay, so might be this is you are on the right path,
yeah,
yes? Yes?
I wrote it wrong, yes.
Okay,
It's
so
plus.
so everyone agrees with Yenny's, yes? Okay, so that's good. Okay, so let me just do, if you haven't done that yet or you didn't understand, let me see why. So what is in this one here? This is easy. I am sending x to g. Oops. I cleaned that one. So what was f? Sorry. X. F was what?
2x plus 5.
Plus 5. And what was g? Thank you.
5 minus 3x.
Thank you. Okay. So what? This one is easy. What is that one? 5 minus 3x. Yes? But then I am sending this again to the same machine. Yes? So what will be the output? It would be 5 minus 3 times 5 minus 3x. Agree? And before doing that, it is better to simplify it algebraically. 5 minus 15 is minus 10, and then plus 9x. Agrees?
Yes.
Do you agree?
Yes.
Okay. And then I am sending this, but this time I am sending it to machine F. So what will happen? The machine F multiply the input by 2 and then add 5s to it. Yes, so what happens is it becomes 2 times minus 10 plus 9x plus 5. And then of course I will try to simplify that. It becomes 18x minus 20 plus 5 is minus 15.
Yes.
It's 18x minus 15, yes. Or minus 15 plus 18x, they are the same. Yes? But let me ask you one question. This is very normal, but the mathematical notation, I want you to discover it yourself. It is a little bit strange. Let me tell you something. So if I have this,
Yeah, you include.
okay. Now, do you remember I told you that in general, if I don't know the rule, what can I write? I would say that x is sent to f. What is the output? Mathematical notation for the output?
Y.
Y, no. If I want to use, Y is correct, but I want to use f and x. F of x. This is the out. Okay? Now, I want you to see what is happening. What happens when I compose the functions? Here, which function is applying which is applied first? Which function is applied first? F, and then g comes after that. Okay, so can you tell me what would be the output here? The output of this is
f of x.
f of x. And then I am sending it to g. What will happen?
G of f of x.
G of f of x, exactly. And this is a little bit unfortunate. You have to come up with it. If you write it in machine 4, it is very natural. We go from left to right.
Yes.
But if I want to write it in mathematical language, it is the other way around. So, but this is not very strange if you get used to it. So when I say g of f of x, which one is acting first?
F.
F is acting first, the inner function. This is called the inner function, and this is called the outer function, yes? So the inner function should apply first. And this comes very natural. You see, you discovered it yourself.
Right.
That is the same thing. You apply to f first and then g, but in mathematical language, it is g of f of x. Is that understandable? And this function, okay, so forget about that. Let us keep it like this. So remember that if I ask you, there are some exercises in the book, they have asked you to calculate this. Don't get confused. Which one should apply first? The inner function. F gives you an output. The second function will apply on the output coming out from the first function. Yes? Is that right? Okay. So these diagrams, I don't know, it's a very good way to learn functions, but this is not in the book at all. But these, you need to learn. Of course, I will leave it myself. Every now and then to illuminate something, I will go and come back to the diagram. But in principle, we should stick to the mathematical notations, which are more compact and easier to do. Yes? But especially for this case, if you have several functions, for example, if I have f of g of h of x. So which one acting first?
H.
H. And then after h?
G.
G. After g? F. So you have to start from the inner function. So let me give you an example here. Okay? So I would write it like this. I would say that let f of x be equals to 2x plus 5, g of x be equal to 3 minus 2x, and another function h of x be equal to, yeah, it doesn't matter, x plus 1. Determine f of g of h of x and g of h of f of x. Yes, just do it. You ready?
Wait.
Yes.
By the way you write it properly is also important in the exam. So if I give you this in the exam and I ask you to calculate, I want to write it in this way. First of all, you understand which one is supposed to act first. Which one? H. So what does it mean? It means that you have to copy and paste everything up to that point. And then instead of h of x, when h acts on x, it will give you 1 unit more. Yes? So it will give you what? X plus 1. This is the way that I expect you to write in the exam. So the inner function applies on x. According to the rule of the function, it adds 1 unit to the input, which becomes x plus 1. And now this is the g term. G is supposed to apply on the input, the new output that is generated. This is the input for G. But G, this is the rule for G. 3 minus 2 times the input. So then you have to write it in this way. You have to copy and paste this F for the time being. And then you have to write 3 minus 2x plus 1. Yes? Of course, I can start working with f with this, but I prefer to simplify and continue. So the next step is simplification. You see, I copy and paste f again. Minus 2x minus 2 plus 3 is positive 1. Yes? And now this is the turn for f. What is the role of f? F multiplies the input by 2 and add 5 to it. Yes? So then what happens here? The input is multiplied by 2 and 5 more is added to it. And then you simplify. So it becomes minus 4x plus 7. How many of you got this exact answer? That's good. 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 So it means that you are exactly on the safe side. And you can do the other one yourself. But let me ask you a little bit more nicer problem. So if I give you the function like this. Okay, let me just use a little bit of diagrams here. Sometimes you don't know the input in a very nice way. So what I mean, I would say that x plus 3 goes into the function and it gives you 5x minus 3. So sometimes you might see, and for not being confused, let me put a pair of brackets around them, even though it is not necessary here. Then I ask you, using this diagram, answer this question. Answer, what is f of 5? I draw a diagram for your function, but naturally, I always use letter x for my input, but this time, for some reason, I have chosen to put x plus 3 as my input, and that is my output. I want you to see how do you interpret. If you can interpret it, it means that you really understood what's going on about functions. And I'm asking to calculate f of 5. Yes, Ali?
7.
7, yes. How did you find that?
Because we know that f of 5 or each x plus 3 should be 5. So
exactly. So what from this, how we understand that if we put x plus 3, if I put a number x plus 3 as my input, the function will take the x part, multiply it by 5 and subtract 3 from it. Yes? Yeah. Now my input is 5. So what is the x part of 5? In this case it is 2. Yes? Because 5 can be written as 2 plus 3. And if I compare the 5 in this form with that, I read that x should be 2. And then I have to put 2 here. Be careful about that. Is that understandable for everyone? Yes? So if I ask you here, the answer would be 5, but instead of x, I put 2. Yes? So then it becomes times 2 minus 3, and as you said, the answer is 7. Understandable for everyone? I want to make it a little bit harder. If I ask you what is f of x, I want to hear from you.
Well, is x a separate thing from x?
That is the interpretation. I told you that. Don't ask this question. Yes, x is just a representative for an input. If you want, you can choose it A, you can choose it B, whatever you want to. But that is a well-defined question in mathematics. It doesn't mean this x is that x or whatever. You have to have an interpretation for the diagram as a whole. Yes? This is a little bit confusing, but I want you to think, because if you can learn it yourself, you can save my bread, okay? Yes. So that question, that your concern, I understand. You are asking this x is the same x or whatever it is. Yes, they are actually meaningful questions. But I want you to understand, when you want to interpret a function, names are not that important. The operation, how it acts, is important. Yes? And it doesn't matter how do you interpret that. Recording, yes?
Could find it as
I want your answer, okay?
f of x.
Instead of question mark, what am I supposed to write?
5 times
So Rasmus, yes?
yes
5 times,
x minus 3
like this?
yes
Yes?
minus 3.
Minus 3. Okay. How many of you agrees with that? How many of you agrees with that? Of course, if you want, you can simplify Rasmus' answer, yes? So it becomes 5x minus 18. Yes? No problems, but that is good enough for me. So how many of you agrees with that? Raise your hands. How many of you disagree? So what about others?
I think the answer is 5x plus 12.
5x plus 12. So how did you bring that? Ali?
Instead of x for the function f, I took x plus 3.
No. You didn't do the same thing. You answered me for 5 yourself. But now you are doing something else. So just I want you to say that these questions are exactly the same thing. But here, this is numerical. This is algebraic. I want you to have understanding. So here, you discovered your x to be 2. Yes? So what you did, you subtracted 3 from this number. You got 2. So Rasmus did it correctly. He subtracted 3 from x. He got it x minus 3, and then replaced the x with x minus 3, and that is exactly what Rasmus mentioned.
I thought the x meant that it was the input, the whole input.
Yeah, that is the whole input. No, that's exactly, this is what I want you to learn. Yes? This is completely, there is no mistake going on. Okay? You have to have your interpretation correctly. So this is completely well defined. In mathematics, I can say that if f acts on x plus 3 gives you 5x minus 3, this is my assumption, and I can ask you what will happen if f acts on x. Okay? Of course this x and that x are different, but you shouldn't care about the names when it comes to functions. You need to care about how a function acts. And try to read it with English or Swedish or whatever language you want in your head. Yes?
So in this case, you can, like, x is x plus 3. And, like, x as the function when you
Yes.
ask what...
Yes, so I can call it capital X as my input and try to see what will happen here. Because if capital X is x plus 3, then little x is capital X minus 3. And that's exactly what Erasmus did. So if I send in x, the answer would be 5 little x, but little x is capital X minus 3 minus 3. And the name is irrelevant. I can change it to little x again. Be careful, let me write, this is very important for functions. If I write this function, and if I write this function, and if I write this function, let me write it in that way. So what can you say about these functions? I intentionally using different letters, little f, capital G. Okay, what is your opinion about the role of these functions? Are these functions different functions?
No. What? They multiply to...
No, this one, if you want to read it in English, it's multiplication by 2. What is this function?
Multiplication by 2.
Multiplication by 2. What is this function? Multiplication by 2. So you see that this is important. Of course, is this one and this one and this one identical? No, everyone can see the differences. Little f, capital G. But the way as a function, they are the same functions. And the name of the function is multiplication by 2 function. Do you understand me?
Yes.
So, for example, if I want to solve this problem, I can teach you the trick, but I want you to understand the trick works. So here, if I want to solve this problem, I would say that usually I do not put this as my input. So I would say that let me call x plus 3 to be capital X. And then let me rewrite this in terms of capital X. So what will happen? This becomes, please listen to this part, f of x is equal to, from here, little x is capital X minus 3, I put it there, it becomes 5 capital X minus 3, and then let me simplify. This becomes 5x minus 18, yes? Yes? But now, let me ask you some question. Is it mathematically valid? And then I would say, let me replace capital X with little x. If you don't understand what is going on, you might object me here. Because you might say that, okay, you told me x plus 3 is capital X. But now you are telling me, take it away and put a little x. How is it possible? Do you understand what I mean? This is at the level of interpretation of functions. So this function is multiplication by 5 minus 18. What is this function? Multiplication by 5 minus 18. So it doesn't matter if I use the letter x again, not because x and capital X are the same. They are not the same. The way that I interpret that, I don't know. This is a little bit subtlety in functions. If you understand that, that definitely you will have a very good understanding of functions. Is that clear?
Yes.
So here, I introduce you myself a variable to make algebra simpler. If I want to, I can leave it like this, but usually the letter reserved for the input variable is little x. If you want, you can stop the problem here, but I myself prefer to go back and write it with little x. Is that understandable? Switching the capital X with little x might be confusing. You might tell me that they are not equal. So how is that, Babak, you are replacing capital X with little x? I want you to understand this point. Do you understand that?
Yes.
Okay, good. Okay, let me make it a little bit harder. If you understand that one, I want you to answer this question, and that will be the last question, okay? Okay, so I will tell you this. Let g of 2x minus 5 be equals to 2x. Let me avoid divisions, might be it's confusing. So 3x plus 10. Determine g of x. I will pause the video, wait for you for 5 minutes, and it takes me 3 or 4 minutes to solve it, and then we are done. Okay, let me ask you one question here. Here, if I want to do it simpler, as I think Rasmus did it in that way, so you can switch x to x minus 3 in this problem, and you can solve it easier. Because if I switch x to x minus 3 plus 3 becomes x, and then x becomes x minus 3, and then I am done. Yes? That is the same idea here, but understanding it is not that easy like that. You can have a good guess, but I prefer not to guess. Use algebra. This trick I want you to learn. Yes? So what I will take this one and call it a variable. For example, let me call it this time capital T. whatever you want to. Yes? And then you make x your subject and find x. How? I add 5 to it, it becomes 2x equals to t plus 5, and then I divide by 2. I don't know which way you want to divide it by 2. I can write t plus 5 overall divided by 2. This is my x. Or if you want, you can write t divided by 2 plus 5 divided by, that's okay. But then what I do, I will go back to my original equation. Instead of this one, I put capital T. And instead of this little x, I put that expression.
Det var det han gjorde, men det var ju inte åt det hållet.
Yes, if you want, you can simplify it. Let us simplify it a little bit. So it becomes 3 halves times t. 3 times 5 is 15 over 2. And then I have a 10, so it becomes 25 over 2. Yes? So this trick I want you to learn. If you have g of something except x, call it a new variable and try to find your old variable in terms of new variable and rewrite your equation in terms of your new variable. And if you need simplify that, you will get this one. But can you tell me now what gx is? What is gx?
Wait.
Så det här diffet är annorlunda. För förra gången så var det att funktionen var...
So what is g of x? Did I make a mistake here?
Should it be 25 divided by 2? Or I got it to 35 divided by 2.
No.
Or am I missing something?
No, I think it's 25. I think it's correct. But forget about that. That's just a minor thing. But what is g of x? Tell me. This calculation, I got it here with capital T, but now I want to have x little x.
3 over 2x plus...
Exactly. So the role of the function is important. The function tells you that if you put input capital T, the function multiply the input by 3 halves, add 25 over 2 to it. Now I am asking the same question for the function for little x. What is the answer? It becomes 3 over 2x plus 25 over 2. That would be the answer. Yes? Yes or no? Okay. So the topic of the function, yes, please.
How did you got t plus 5 divided by 2?
Yes.
How did you go to...
So here I go back to my equation.
Yes.
Instead of this one, I put capital T. Instead of this x, I put this expression in. Yes. So it becomes 3 times that plus 10. Yes? Okay, we will continue with the topic of functions for some sessions. That's very important. Any questions? Okay, I will write on Google Classroom which pages in the book you are supposed to study for this lesson. Any questions? Thank you.